Hi everybody, welcome back. I made a mistake. So I should have added 3 to your y's because your square wasn't up here. Your square was down at 0. So only add 3 to your x. And then when you plot that new point, ta-da, it's in the middle of your square. Yes. Yes.
Duck.
Be careful. Duck. All right, let's get the other one. Do you guys agree that the right angle went over 3 and up 3? All right, so this one we are going to add 3 to both of them. So I get 4 and 4. So if I get 4 and 4, hopefully, that looks so much better, doesn't it? All right. So all we have done is find the centroid of each one. Now, this is one big fat shape altogether, right? Therefore, the centroid is like, I'm going to try to say this the right way. Try to make it as real as it is. The main centroid is a combination of those centroids. The rectangle is the biggest item. Therefore, the centroid is going to be the closest to the rectangle. The triangle is the littlest item. So the centroid, it won't have as much of an influence on the centroid. So the item that's going to have the most influence on the centroid is the rectangle. So you might notice your centroid being pulled to your rectangle when we're all done. And here's how we finish. You use the magic chart. Shape 1 was the triangle. Shape 2 was the square. Shape 3 was the tall rectangle. The area of my triangle is, thank you. I wonder if there's somewhere easier to find the area. Maybe up here. Let's find the area up here because I didn't give you much room down there, okay? Right here, let's write area equals 1/2 3 times 3, right? Base times height. What's the area of the triangle? Area of the triangle. What's 3 times 3? What's 1/2 of 9? Good. So there's the area. Let's do the area of shape 2. So area of shape 2 is length times width. So it's 3 times 6, which is good. And now let's do shape times 3. Shapes times 3. Shape 3. So it's a square, so it's a length times a width. So 3 times 3 is, all right. Now we can just do the trick, fill in the numbers. Missing student of mine who just went to get water. We had to find the area of each of those. Okay. So the area of shape 1, which was the triangle, is 4.5. Area of shape 2, which was the taller rectangle, was 18. The area of shape 3 was 9. We may as well fill this in over here too. I'm on fire today. I'll try to get to you after physics. All right. In shape number 1, what was the x bar of shape number 1? 4. What was the x bar of shape number 2? Yep. What was the x bar in shape number 3? 4. Let's go over here. Let's do the y bars. What was the y bar of shape number 1? What was the y bar of shape number 2? What was the y bar of shape number 3? Now what you're going to do is multiply those together. So multiply these together. What's 4 times 4.5? Good. Doing it in my head. And I'm going to change these to blue because I don't like black. Okay. What's 18 times 1.5? What's 9 times 4.5? Okay. What is it? 40.5. Perfect. Okay. Now let's go over here. Okay. And if you guys can, no, we're not going to notice anything yet. Let's go ahead and multiply these two. What's 4 times 4? Oh, we already have that, 18. What's 8 times 3? 18 times 3. And what's 9 times 1.5? Nice. Now what we do is we add all those up. Add those together and let me know what we get. 85.5?
Oh my god. Did y'all
Seriously. I'll have her wait. Tell me. 85.5. Sorry, I got distracted again.
triplets?
Almost walked into the wall. She said she did hear it. She goes, I almost walked into the wall.
It's been a long week. Add those up. Ooh, are they the same? Okay, let's make sure we talk about this. Don't assume that those are always the same. Good. That's probably a good thing to say. Now what I want you to do is add all these up. Add all the areas up. 31.5. Okay. Oh, and this is going to be the same, right? 31 area is going to change. Last step. You take this number, divide by this number, and you will find the x centroid for the big object. So you're going to do 85.5 divide by 31.5, and give me 4 significant digits. Good. And we'll just put UN for units, whatever the units are, be centimeters, inches, millimeters, meters, whatever. And do the same thing here. So we're going to do, it's going to be the same, isn't it, guys? Okay. Again, let's definitely not make an assumption that they're always the same, because they are most definitely not always the same. Now what we're going to do is we're going to draw it. We're going to go up there. We're going to get, I'll put it in brown, because why not? We're going to go over 2.74, up 2.74. Oh, so over 2.74, up 2.74. That is your centroid. And it makes sense to me. Didn't we say that the rectangle held a larger majority of the mass? Isn't the centroid kind of within that a little bit more? It's a way, even notice it's like if this is where the triangle is, the centroid is actually just a little bit below it, because the triangle isn't as much of a weight or a percentage of the overall object. That was fun.
Mm-hmm.
I think it's kind of cool. So you can do it like that, or if you flip the page, it's the same problem. You can do it a different way. So that's how to do it with 3 individual shapes. What's kind of cool is if you guys notice, some people see one big shape, take away one small shape. So you can take shapes away. So do you guys see how it's overarching? Would that be that'd be a square then? A really big square minus a really small triangle. So instead of doing 3 shapes, we can do 2 shapes and just make the triangle a negative shape. Okay, so shape 1, let's do it as a square. It's a 6 by 6. How about we just put the area inside of there? 36. Shape 2, it's a weird triangle like this, which is a 3 by 3. So let's put the area in there, 4.5. We don't even, so we can completely eliminate a shape 3. We don't need a shape 3. So shape 1 is our square. The x bar is half of 6. So it's 3. It's again half of 6. So it's 3. Now if you see the triangle, the base of it's 3. The height of it's 3. So it's 1/3 for triangles. It's 1/3. So we get 1 and 1/3. So we get 1. Now what I want you to do is, since we are taking the triangle away, please make the area of the triangle negative. Because we're taking the triangle away. Don't make the x bar and the y bar negative. All right. This really boggles minds sometimes, so let me really I'm gonna try my best to help. But nobody ever likes this particular part. Do you guys like 3, 3 for the square? Does that look good for the middle of the square?
Yup.
Then keep 3 and keep 3, because the square started at the origin. However, we don't like 1, 1 for the triangle, right? That's nowhere near the triangle. So what we're gonna do is I like to go up here to my original shape, and I like to say, remember, this 1 is from the right angle. This 1 is from the right angle. So it's 1, 1. You guys see that blue dot? Remember, it's from the right angle. That blue dot is what? X, Y, point. Over how many? Up how many? And up? Good. So it's actually 5 and 5, not 1 and 1. Now, how I always mathematically explain that, I say when the triangle's kind of weird in the wrong spot like that, what you do is you take the end of the triangle, which is at 6, and you subtract what you get. And you take the top of the triangle, which is at 6, and subtract what you get. So please make sure, always verify that what you put as your x bar and your y bar is where it is graphically. Did that sentence make sense? Where your x and your y bar is where it is graphically. So the area is 36 for my square. The x bar is 3. The other x bar is 5. The area for my triangle is -4, 5, and -4, 5. My x bar is 5. My x bar is 5. Or y, x bar is 5, y bar is 5. So I'm filling it in just like I did in the last one. I went slower on the last one too first time. What do you see? What's questioning? The y bar for the first one. Good call. This is a 5. That's a 3. Good. I did that on purpose. Good job. It was a good catch. What not to? Okay. What's 36 times 3? 108? I'm so scared to write things on the board right now. 108? Good. What about 4.5 times 5? All right. And just because this is the same problem, guys, we're going to have the same numbers, right? Remember I was like, but don't always assume they match. These match because it's the same shape from last time. Every year I think I should change that. Every year I don't. What do you get when you add these together? Ah, and that makes sense, doesn't it? That should be a really long time. I'm going to guess that you're going to get 31.5 for the other ones, right? Because, it doesn't matter if you do it the way we did it last time or the way we do it this time. And then just like the last problem, you take this number, you divide by this number, 2714. Is that what we got? All right, so same thing. Do you guys feel confident with your centroids? All right.
30 seconds left.
Boom. Is that the end of the notes? No way. All right, I'm gonna let that run out. I'll do a little. Oh, there's more. What else do we have to do? I feel we're almost there, right? Oh, these are gonna go fast.